So now we have problem 3. Um, so what we have here is just like the situation with the finches, right? So we have 2 samples from Gaussian distributions. We don't know the means, we don't know the variances. And what we want to do is we're going to plot the probability of, again, rejecting the null hypothesis that there's no difference between the true means. We can assume that the standard, so we can set the standard deviations for like the 2 samples to 1, and the sample size is 100. Okay. So let's generate data that's like that. So how do you do that? So you can say like, so it's just like with the finches, right? So you'd say S1 is like our norm with n equals 100 because you can assume that this. So the mean, let's defer that for now. And then the standard deviation, we said we can assume that it's 1. And then the second sample is also going to be samples from the normal distribution. So n is going to be 100, mean is this, and SD is also 1. So now, what about the means? So what we're interested in is, like, if the difference between the true means is this much, what's the probability of rejection, right? So one strategy is to just say, well, I'll just arbitrarily set the mean for S1 to 0. And then I'll say, well, whatever is difference, I'll set that to be the second mean. And then, like, if I want the difference to be like 1, then, well, the difference between the means here is going to be difference because diff minus 0 is diff.
Okay.
All right. So we'll do it like that. So now what I want to do is I want to say, well, what's the p-value? So we can actually use t.test for that, right? So you can just say t-test S1, S2. So if you do that, you'll get all of this information, right? So here it gives you the p-value. So apparently the p-value is very low here, right? It also gives you the confidence interval for the difference, stuff like that. So in order to extract, it also gives you the t-statistic. So that's the thing that we computed. So if you want to just extract the p-value, you could say $p.value like this. And that's going to be p-value. So as you see, that matches.
So you couldn't have used PT?
We could. Now it would require us to actually compute the t-statistic and also compute the degrees of freedom, which would be kind of annoying. Now, as it happens, t.test should also, I believe, provide the degrees of freedom. It does, yeah. So here it does provide it, so we could extract it, but like, what's the point? Right? So we can just do p-value. So like, well, for the sake of the exercise, let's actually do it. So we can say t is equal to t.test S1, S2, and this would be statistic. So let's make sure that that works. So this is t. So minus 6.3, and here you have minus 6.3. Okay. So now you can say pt of minus absolute value of t.
So why do you have to do minus absolute value?
So that's just because the t could be positive or it could be negative. So what I want here is like, what's the probability of getting something even smaller than the negative extreme value, right? So because the average, the mean for the t-statistic is always 0 if the null hypothesis is true. So I can just say, well, like, what's to the left of this? And that's the probability of being to the left of the negative version is the same as the probability of being on the right of the positive version. Okay. So I'll just do 2 times pt. And here we'll read the degrees of freedom. So we can say df is 198, so we round up. And here you have the p-value, and hopefully that matches. So this is 1.7, and it does match. Okay. So that's the same. But we can just use p-value, right? So all that we need to do now is we need to just wrap it in a function, right? So let's call it again. So so this is like the p-value, right? So the name here was like p-val r. So let's call it like p-val t, right? And here it's going to be a function, and we'll give it diff, and we'll return the p values, right? So what's going on? Oh, I forgot the. Okay, so we can try running it. So let's say p val t. So let's say the difference is 1. So now the p value is like this. And generally, they're going to be pretty tiny. So if I make it like 0.1, it's still really tiny. If I make it 10, it's still tiny, 0.0001. That is still tiny. That is implausible. So t-test. So here we're saying, oh, because I set diff to 1, sorry. So I was going like diff equals 1 always, yeah. So, okay. So, yeah, so here it's actually pretty small, although surprisingly. So here,
right. So like the closer it is to
so
0.
the closer you are to 0, so the closer these two sets are to each other, the less likely you are to say that you have strong evidence that they're different, right? So that makes sense. So now we'll do the same old thing. So we'll do sapply. So let's say diffs, and we'll define diffs. So as we see, kind of like in order to get, so we're not there yet. So we actually need like a propreg function, right? So propreg3, and we'll do function diff, and here we'll do the same thing. So we'll repeatedly do p-val t, right? So we'll say replicate. Let's say 1000, and we'll say p.val.t, and we'll say diff, and we'll ask how often is that smaller than 5%. So we'll return the mean of that again to get the proportion of the times that this is smaller than 0.05. Okay. So propreg3 of like 1 is gonna be no. So let's try this. That is not working. So here we're saying replicate. Oh, because no, I just
okay.
Yeah. Okay, so still no. Wait, hold on. I didn't. Okay, so the probability of rejection, if the difference is 1, is just 1. The probability of rejecting if it's 0.1, it's 0.97. 0.01, the probability is very low. Okay, so we'll make a vector of diffs like this. So it's gonna be, so let's start with like 0, and then do 0.001, and then 0.0.01, and 0.1, and 0.15, and 0.2, and 0.5, and 0.7. So just to get like something interesting. So that would be like that. And now we'll again sapply. So opreg is going to be sapply. Diffs function is prob.reg3. And pregref is going to be data.frame. And we'll say diffs is just diffs. And probability of rejection is opreg, this. And now we can again display it. So I'll just copy this. So P reg df, and here X is gonna be, so usually I prefer singular, so I'll say diff, and Y is gonna be, let's call it prob reg again. So I'll rerun this, and now I plot this, and I get kind of like an increasing probability of rejecting as the difference becomes larger.
That makes sense.
All right.